Hello students, this is I am going to explain today a few more examples on interpolation. Okay, example 2, you see that find e raised to 0.35 given data are like this. Okay, x values 0, 0 0.1, 0 0.2, 0 0.3, 0 0.4, e raised to x. Okay, y it is fx equal to e raised to x. It is in the form of exponential e raised to x is 0.35, this one. Y is y value or fx value, this is e raised to x. E raised to x value they given like this 1.000 like this, 1.1052, 1.2214, when x equal to 0.3, y is equal to or e raised to x equal to 1.3499, and when x equal to 0.4, y equal to 1.4918. Okay, these are arguments entries. Okay, solution, let fx equal to e raised to x, okay, or y is equal to e raised to x. Okay, to find e raised to 0.35 equal to, it means f of 0.35, this is where which is near the end of the table. You see that this value, you see that 0.35 near the end of the table. Okay, therefore here we use Newton's backward interpolation formula. If this x value lies near the end of the table, then you can use Newton's backward interpolation formula. If it is lies beginning of the table, already we have discussed in the example, first example, Newton's forward different interpolation formula we have used. Okay, here xr is 0.35. Whatever they want to e raised to, they want this value e raised to 0.35. It means f of 0.2. This is xr. We have to take this is xr equal to 0.35. So xn is here xn we have to take last value. This is our table 0.4. This is xn. Okay, when you are using beginning of the table, x naught you take. When you are using last end of the table, you can use xn you take. Xn equal to 0.4. H is so equal interval of differencing h equal, that is 0.1 minus 0, 0.1, 0.2 minus 0.1, 0.1, 0.3 minus 0.2, 0.2, h value, this is h is 0.1. So equally spaced. Okay. Therefore, R value you get okay, R value you get xr minus xn divided by h. Okay, already I have given this. R value, R is given by this. Substitute all the values here, xr value, xn value, h value. Use calculators, simplifying by using calculator you get minus 0.5. This is okay. Here f of xr, Newton's backward interpolation formula, use that. F of xr equal to f of xn minus xn plus rh, here written, or xr equal to, you can write xn plus rh. F of xn, this is given by the formula f of xn plus r by factorial 1 del for backward interpolation, backward difference operator you have to use, backward difference operator del it is used. For forward it is delta is using, okay, capital delta. It is del of f of xn plus r into bracket r plus 1 divided by factorial 2 del square of f of xn plus r into bracket r plus 1 into r plus 2 divided by factorial 3 into delta cube of f of xn divided by factorial 3 plus etc. You say this is equation 1. Okay. Now you construct the backward difference table. The method is similar, but only you have to write. We are using this operator del for backward. You can write, you can say backward difference table or simply difference table you can say. Okay. Find the write the arguments and entries. Arguments x value 0, 0.1 in the whatever they given in the tabular value, you write in the vertical form, okay, x values 0 0.1, 0 0.2, 0 0.3, 0 0.4. These are the x values. Arguments, entries of x value. These are called entries, fx value, functional value at x value. 1.000, 1.1052, 1.2214, 1.3499, 1.4918. Okay, taking difference similar. Okay, you can find out the difference of these two. My 1.1052 minus 1.000, it gives 0.1052. Okay, similarly 1.2214 minus 1.1052, you get 0.1162. Taking difference of these two, 1.3499 minus 1.2214, 0.1285. Similarly, 1.4918 minus 1.3499. Okay, difference you get 0.1419. Okay. Similarly, this is the first order difference. You can say this is the procedure, same, finding forward difference and for backward difference, same, only symbol you use here. Okay, here. Similarly, delta square, second order difference. This 0.1162 minus 0.1052, 0.011. Similarly, 0.1285 minus 0.1162, 0.0123. Then again, 0.1419 minus 0.1285 gives a 0.0134. Okay. Similarly, third order difference. Third order difference is given by, so 0.0123 minus 0.011. Okay. It gives a 0.0013. Similarly, next one 0.0134 minus 0.0123. This gives 0.0011. Okay. Finally, delta fourth, del fourth, fourth order difference. Take the difference of these two, 0.0011 minus 0.0013 gives minus 0.0002. Okay. This is the difference table. Okay. Then above formula, that is interpolation formula, gives a substitute x value f of xr, this is a f of 0.35 equal to you see that f of xn, whatever you can, end of the table, you see that end of this f of xn is this. Okay, I have shown by dotted line here. And you have to take for this is a backward difference. If it is a value lies end of the table, at the end of the table, you can use the end of the table values here, all the differences. In the last example, you have used the beginning of the table. Okay, this corner too. Okay, there you say f of x naught, delta of f of x naught, delta square of. Here you say that f of xn, delta del of f of xn. Here del square of f of xn, del cube of f of xn, del fourth of f of xn, like this. Okay. Here this is f of xn value 1.4918 plus here you see that r by factorial 1, r value is minus 0.5. Okay, r value you got here minus 0.5. You see that minus 0.5 into delta of f of xn, this is 0.1419. Similarly, plus r into bracket r plus 1. That is r value is minus 0.5 minus 0.5 plus 1 divided by factorial 2 is 2. So, into delta square of f of xn. Delta square of f of xn is 0.0134. Substitute here. Similarly, plus r into bracket r plus 1 into bracket r plus 2 divided by factorial 3 into delta cube of f of xn. Okay, substitute all the values, r value and delta cube of f xn is 0.0011. Similarly, one more, you can write r into bracket r plus 1, r plus 2, r plus 3 divided by factorial 4. Factor 4 is 24. Okay, substitute r values, minus 0.5 everywhere here, and delta fourth of f of xn. here last value minus 0.0002. You substitute here. So using calculator, all you simplify. Okay, you get first value as it is 1.4918 minus 0.07095 minus 0.001675 minus 0.00006875 plus last value 0.0005078. Okay, if you add all these, you get finally the value of e raised to 0.35. Okay, 1.4191. Okay, this question. You see one more example. This is you can try at home. Example 3, find the value of similar type. This is find the value of e raised to 0.24 from the table 0.24. Okay, this is lies beginning of the table. This value yet exponential y is equal to e raised to x, or y you have to write here. These are exponential. Y is equal to e raised to x. X value is 0.24. Here 0.24 lies beginning of the table. Can use forward interpolation formula. In the first example, you refer first example. Okay. You see one more example. Example 4. Estimate f of 4.2 from the table. Answer also I given here. Okay. You see, please. Okay, check up that. You see that estimate f of 4.2 from the table. Use tabular values are given like this. Okay, this also you can try. This value, you see that this is the beginning of the table. Refer example 1. This is a lies end of the table 4.2. Refer example 2. Similar type. Okay, answer also I have given here. F of 4.2 is 76.088. You can compare the answer. Okay, then second you go. This is the up to you have discussed interpolation with the equal intervals. Okay, you see that second one, interpolation with unequal intervals. Here, if the given data is such that the values of x in it are not equally spaced. Okay, h values are not same. Okay, spaced. Then we cannot use Newton's forward and backward interpolation formula. In such case, we have the following two formulae. First one, number one is Newton's divided difference formula. Second one, Lagrange's interpolation formula. This is Lagrange's formula, simply you can say. Very first, you see that what is divided differences. Divided difference means, suppose we have a set of values f of x naught, f of x1, comma f of x2, etc., f of xn of a function f of x corresponding to x equal to x naught, x1, comma x2, etc., xn, which are not necessarily equally spaced. That is, the difference between two consecutive values of x need not be equal. Then we have the following definitions and notations. Okay, you see that first one, the first divided difference for the arguments x0 and x1 is defined by f of x0, x1 you have to write here. And this can be, sometimes you have to write a divided difference operator, you have to write delta like this. In the middle you have to divide it. Okay, for it, that indicates divided difference. Okay, delta of, you read pronunciation divided difference operator of f of x0 operating on. You can say that del divided difference symbol. This is divided difference symbol, del of f of x0 equal to f of x1. This is given f of x1 minus f of x0 divided by x1 minus x0. You see that? Okay. Then similarly, the first divided difference for the arguments x1 and x2. This is the above is x0 and x1. You see that how to write x1. Similarly, x1 and x2 is f of x1, x2 here. Okay. In the place of x0 is x1, in the place of x1 is x2, like this. So this can be denoted by del of f of x1, you can write. Okay. Whenever writing divided difference of x1, x2, you have to write like this, del of f of x1. So can write this f of x2 minus first one. You see the beginning of f of x2 this, next minus f of x1 of this, divided by whatever you have written is x2, x1, same without function you write, only you have to write x2 minus x1, okay, by remembering purpose you can. Okay, next again similarly you see that f of x2, x3, that is divided difference for the arguments x2 and x3. Similarly with that del of f of x2, okay, f of x3 minus f of x2 divided by x3 minus x2, okay. So, continuing this way, in general the first divided difference for the arguments xr and xr plus 1 is given by general xr and xr plus 1, okay. F of xr comma xr plus 1, or this can be written as del of f of xr here. You can remember this f of xr plus 1, higher one, minus below of that, lower of this, f of xr, okay, divided by xr plus 1 minus xr, okay, okay. This is one time. Then second one, the second divided difference for the arguments x0, x1, x2, that I am taking it as that is f of x0, x1, x2 you can write, okay, that is a second order, that is a del square of f of x0 you can write, equal to, this can be written as f of x1 comma x2 minus f of x0 comma x1 divided by x2 minus x1, okay. x2 means last one, x2 minus x0, first one, okay, x2 minus x0, x2 minus x0, like this. In general, the second divided difference for the arguments xr minus 1, xr comma xr plus 1, okay, decreasing, you see that increasing by 1 1, increasing by 1 1, xr minus 1, xr, it is 1 greater than this is 1 greater than this, like this, the increasing order you have to write. This is given by seeing the nature of above, you can write first f of xr minus 1 comma xr plus 1, this is equal to delta square of f of xr minus 1. Here you have written f delta square of f of x not the first one, like that, f of xr minus 1. This can be written as f of xr middle one. How you have written f of x1, x2 like this, x1, x2 like this. Then last one, first one and last one, f of first one, middle one, like the f of x0, x1, like this, comparing. Then finally divided by x2 minus x1, your last one minus first one, like this. Similarly, you write this is a f of xr, comma xr plus 1 minus f of xr minus 1 comma xr whole divided by xr plus 1 minus xr minus 1, xr plus 1 minus xr minus 1, okay. In general, the nth divided difference for the arguments x0, x1, x2, etc. xn is given by f of x0, comma x1, comma x2, etc. xn equal to delta n of f of x0, you can write. So, similarly, by seeing the above nature, f of x1, comma x2, etc. xn starts from x1, okay, x1, x2, xn, like this, minus f of x0 starts from x0, x0, x1, x2, etc. One less than xn, like that is xn minus 1 up to xn minus 1, not xn, up to xn minus 1, divided by xn minus x0, xn minus x0, okay. You see that how to construct difference table, okay, example one, just explain how to construct a divided difference table for the data. X is given like this, fx values are given, okay. Here we observe the table, arguments x are not equally spaced. You see that 2 minus 1 is 1, 4 minus 2 is 2, 7 minus 4 is 3, like this, 12 minus 7 is 5, like this, different, not equally spaced. So, we construct the divided difference table. So, that is called divided difference table, you can construct here. So, you see that write the x values arguments, entries. Okay, x value is 1, 2, 4, 7, 12. Here fx value is 22, 30. Fx2 I have written f of x1 here, f of x0, f of x1, f of x2 82, f of x3 is 40, 106, f of x4 is 216. Okay, I have taken very beginning to want to explain, I have taken like this. Okay, you see that difference, you take that how mentioned here, first order difference here, 30 minus 22 divided by 2 minus 1 like this, 2 minus 1 like this. Okay, equal to 8 it gives, that is this is a f of x naught x1, this is first order difference, divided difference. Okay, similarly next 82 minus 30 divided by 4 minus 2, this is 4 minus 2, 26 like this. Next one 106 minus 82 divided by 7 minus 4 equal to 8 it gives. Similarly 216 minus 106, f of x4 minus f of x3 like this, 216 minus 106 divided by x4 minus x3, x4 minus x3, 12 minus 7, that is it gives 22. Similarly second order, you see that second order, comparing theory you can write here it is very simple, you see that 26 minus 8, this is very simple, 26 minus 8, but in the denominator f of x naught, x1, x2, then x2 minus x naught you have to take. Okay, that is in the denominator 4 minus 1 like this, 4 minus 1, x2 minus x naught, 4 minus 1. Okay, then here 8 minus 26 divided by x3 minus x2, like this, 7 minus 2, x3 minus x1 like this. Okay, this can be written as f of x1, x2, x3 like this, f of x1, x2, x3. Okay, this gives a minus 3.6. Similarly, last 22 minus 8 divided by last one x4 minus x2, 12 minus 4. This gives a 1.75 like this. Okay, this is second order. Third order is 3.6 minus 6 divided by you have to take x3 minus x naught, 7 minus 1. Okay, 7 minus 1 you write, 7 minus 1. Okay, f of x naught, x1, x2, x3, x3 minus x naught, here x3 minus x naught like this. Okay, for understanding purpose I have written this x3 minus x naught. Okay, next one 1.75 minus minus plus 3.6 divided by 12, that is x4 minus x1, x4 minus x1 like this, 12 minus 2, 12 minus 2, you see that, this is use 0.535 like this. Okay, last delta fourth, here you see that 0.535 minus of minus plus 1.6 divided by 12 minus 1, 12 minus 1 means last one x4 minus x naught, 12 minus 1, x4 minus x1, this is f of x naught, x1, x2, x3, x4, x4 minus x naught, this gives 0.194. Okay, this is divided, how to construct the divided differentiable I explained here. In the here I will stop here. In the next video I will explain the Newton divided difference formula and the related examples. Okay, thank you.